This screencast demonstrates the use of reactor models R-stoich, R-Gibbs, R-plug, and R-CSTR through an example problem on the production of ethyl acetate. Open your Aspen simulation and begin a new flowsheet using metric units. To start, enter your components: ethanol, acetic acid, ethyl acetate, and water. Choose NRTL-Hawk as your method. Watch the related video to learn more about choosing a property method. When all information is entered, run the property analysis and then go to the simulation environment. To run all 4 reactors in one simulation, create a duplicator block, which duplicates an inlet stream and can send it to multiple locations. Create a R-stoich, R-Gibbs, R-plug, and R-CSTR reactor, renaming each as such. Add a feed stream into your duplicator and connect the duplicator outlets to each reactor, naming the streams F reactor type. Create product streams from each reactor, naming them P reactor type. When you're done, your flowsheet should look like this. Click the green next arrow to specify the feed conditions. The stream enters at 70 degrees Celsius and 1 atmosphere. Input the following parameters in kmols per hour: 8.892 water, 186.59 ethanol, and 192.6 acetic acid. Click the green next arrow to go to the duplicator block. There is no information to enter here, so click the green arrow again. For the sake of comparison, all reactors will be specified at 1 atmosphere and 70 degrees Celsius. Make sure all reactors have vapor-liquid selected as the valid phases. For the CSTR, specify a volume of 0.14 cubic meters. You can see that the R-CSTR model requires a reaction to be entered before you can proceed in the simulation. At this point, scroll down on the menu tree and click on the Reactions folder. Click New, leave the label as R1, and select a power law reaction type. Click New again, and enter the forward reaction. Ethanol plus acetic acid goes to ethyl acetate and water. Assume the reaction is first order with respect to each of the reactants, and 0th order with respect to each of the products. Enter -1 and 1 for the coefficients, and 1 and 0 for the exponents of your reactants and products, respectively. Now enter the reverse reaction. Ethyl acetate plus water goes to ethanol and acetic acid. Enter -1 and 1 for the coefficients, and 1 and 0 for the exponents of your reactants and products, respectively. Press the green arrow to input the reaction's kinetic information. For both reactions, the reacting phase will be liquid, and the concentration basis will be molarity. For the forward reaction, specify a K value as 1.9 times 10 to the 8th and a E value as 5.95 times 10 to the 7th joules per kilomole. Make sure the units are correct before proceeding. Repeat the procedure for the reverse reaction by selecting it from the drop-down menu. The K value for the reverse reaction is 5.0 times 10 to the 7th, and the E value is 5.95 times 10 to the 7th joules per kilomole. Press the green arrow to go back to the CSTR reaction tab. You can now move the R1 reaction to your selected reaction set. Pressing the green arrow brings you to R-Gibbs. Remember, the reactor is operating at 1 atmosphere and 70 degrees Celsius. Press the green next arrow to move on to R-plug. Choose reactor with specified temperature as the reactor type, and choose the operating condition constant at specified reactor temperature. Enter 70 degrees Celsius. Pressing the green arrow brings you to the Configuration tab. Input a length of 2 meters and a diameter of 0.3 meters. Ensure the process stream valid phases are vapor-liquid. Go to the Reactions tab and select R1 as your reaction set. Pressing the green arrow again brings you to R-stoich. Input your reactor temperature and pressure. On the Reactions tab, click New and input the forward reaction with the appropriate coefficients. Enter 0.7 as a fractional conversion of ethanol. Press the green arrow and run the simulation. Open the stream summary to view the results. You can compare the production rate of ethyl acetate of the 4 reactors. You can see that R-Gibbs actually produces the most ethyl acetate, while R-CSTR produces the least. Additionally, if you click on the CSTR block results on the menu tree, you can see the heat duty required for this equipment. Watch the following video in the YouTube playlist to see an application of the reactors chapter on a chlorobenzene production plant.